We will now demonstrate how to use SineViewer for demonstrating periodic functions and their properties. We will look at things like phase shift, amplitude, both negative and positive. We will also look at beat frequencies. We'll start off with a basic demonstration of phase shift. I can pick my two notes from the drop-down menu. We're going to use the same note for a phase shift and amplitude demonstration. Right now we're going to have our function displayed in degrees, and we've got the sound on. So I've got my two notes picked, and then I'm going to press a 1 for function 1 and a 2 for function 2. They are now both on. Here is our function. We've got an amplitude of 3, it's a sine wave, and we have no phase shift at the moment, and we are centered on the axis of symmetry of 0. It's showing us that the loudness is the full amplitude because they're in phase. Now I'm going to start moving it with my right arrow, and as you get further out of phase, the loudness goes down to 0. We're now 180 degrees out of phase. The loudness is at 0. We'll continue to move. Now we're coming back into phase. The loudness is getting more pronounced. Now we're back to the full value because we're 100% in phase, and that's good. Now we'll start moving back. I'm using the left arrow, and now I'm coming back into phase again, and back at full in phase. No phase shift. We back at maximum loudness. Now I'll start going negative. You'll see that my x minus d value is now positive. So now I'm getting negative. I'm down to totally out of phase. I'm at 0 loudness. The value of that function right now is 0. We'll keep going. And now we're back in phase. To turn off the demonstration, I just hit 0. Now we'll do a demonstration of amplitude. So we'll pick our two functions. So I'm going to pick, I've got my two C notes. I'll press 1, and I'm going to use 7 to make it louder. So now it's at maximum loudness of 5. And now I'll turn on note 2. I'll use my 8 value to make it maximum loudness. So I'm using 8 to change my values up and down, and 7 and 4 to go up and down for the note 1. You're seeing that the two frequencies are the same. Now what I'm going to do here is I'm going to actually use, I'm going to make the second note, the pink note, I'm going to make it an inverse of the original green note. So I will go, okay. So it's totally out of phase. You have a loudness of 0. So now I will start moving it, and you'll see that you have a negative value. The function has a negative a value. My loudness is 0 because I am totally out of phase. Now I'll start moving. It's getting louder as I come into phase, but I'm 180 degrees. The 180 degree shift now gives us full value rather than 360 degrees. I can keep going. I'm now out of phase again, 0 loudness, and now I'll start moving back, and now I'm back into phase, and now we're back to 0 loudness because we're 0 degrees out of phase. We can also use radians for our phase shift units, so I will pick my notes again. This time I will turn off the degrees button, and now it's going to start showing me radians. So now you can see that as I go out of phase, I'm using radians in my display. And as I come back into phase, it gets louder to its maximum loudness. Now, once you get to 9 pi over 4, you can't go any farther, just for the sake of making it possible to store all these textual pi values. We can also go negative, so I can bring it back to 0 phase shift. And now I start going into the negative phase shift and my values are positive. And now we're 180 degree or 100% out of phase. It's 0 volume. If you wish to demonstrate C values, you can just use your up and down arrows. So I can move it up, I can move it down, and that has no effect on the amplitude. Now we'll demonstrate beat frequency. For this, because beat frequencies are easier to hear at lower frequencies, at the very bottom of these lists we have some lower notes. So I'll pick a C1 and I'll pick a C1 sharp. So I'll turn on note 1 and then I'll turn on note 2. You're hearing that wah, 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 wah. That's about 2 hertz. It's showing us the beat frequency between tones 1 and 2 is approximately 2 hertz. So you can use this to demonstrate beat frequency. You also see the relative frequency length of the 2 notes. If you would like to show frequency in terms of one is a multiple of the other, we can pick notes that are 1 octave apart or more octaves apart. So I'll go back here, I'll pick C3, and I'll pick C4. Oops. Turn on. There is C3. Here is C4, and you can see that you get 2 repetitions of C4 in the wavelength of C3. If you'd like to demonstrate triads, you can do that too. So I'll pick a CEG, so I'll do C, I'll do E3, and G3. And so I can just press 1, 2, and 3. And I can hear my triad with the 3 notes. And if you want to do your demonstration with your sound off, you just turn that off and it will, or click that button and it will turn it off, and you will just be able to demonstrate the waveforms without the frequencies. Those are the way you can use this tool to demonstrate periodic functions and frequencies. Thank you.